So hopefully you can kind of see the background information, and in the background information it kind of talks about these steps. So, but let's just do one, and they should seem maybe pretty familiar. Okay. So the one we're going to do first is actually write the Lewis structure of maybe one that we've looked at before. Oh gosh. There's checks at the bottom. We'll get to those. The first one, dun dun dun. Okay, see in the red up there? The first one is NH3. So what we're going to do is now ammonium is NH4+. Ammonia is NH3, the neutral molecule. So we're going to write the Lewis structure for that. So if you would go ahead and go to like one of your blank columns. Yeah, right here on 14.6. And see where it says it has a column there. You're going to fill all that out. I know mine goes across and yours goes down, basically. That makes sense. So at the top there, put NH3. And in the box underneath it, we're going to come up with the pot of valence electrons. Now, for your exam a week from today, you will be drawing your own Lewis structure. So you don't have to do all these steps, but these help reinforce what you do. So remember, we come up with the pot of valence electrons by looking at the periodic table. So nitrogen, there's one nitrogen atom. It's 5A, so there's 5 valence electrons. So my writing is terrible there, but that's 5 electrons. For hydrogen, there are 3 hydrogen atoms. Each of them bring 1 electron, so there are a total of 3 valence electrons brought by those 3 hydrogen atoms. So of course, 5, that's a 5, plus 3 is 8. So that's our pot right there. So yeah, that's where we're at. Yeah, so that's where we're at. So again, on the test, actually what I've done, and I'll probably do it again for this unit of material, is I will have a section where the question is, what are the pot of valence electrons for this molecule, and then not draw the Lewis structure, but do this first step. So then you need to, the next box underneath it is you're drawing what I call the preliminary Lewis structure with the primary sigma bonds. And arrangement of atoms goes something like this, and I mentioned this, I think yesterday. You put the lowest electronegative atom in the center. And your background information for this lab also says hydrogen never wants to be in the center. So if hydrogen never wants to be in the center, of course, nitrogen's going to be in the center this time. So our preliminary Lewis structure looks like this, where we have nitrogen in the middle, sigma bond, sigma bond, sigma bond to the 3 hydrogens. And then sometimes in that box, what I'll do is I'll come up with my leftovers. So what I mean by that is I had a pot of 8, but can you see I've used 6 there? So 8 minus 6 is 2. So sometimes I write it right there. Is that the same bug or a different bug? Gosh, it's kind of cute, actually.
He's just hanging out.
He is just hanging out. And then the box underneath that, you're ready to distribute those extra electrons. And your instructions are to go ahead and turn your attention to the outside, the terminal atoms first. But hydrogen's done. It doesn't only wants 2 electrons, right? It's got 2 there. So hydrogen's done. So if your terminal ones are done, go to your central one. And nitrogen's not done. It wants 2 more electrons, doesn't it? So actually then in the box underneath that, we're going to go ahead and put those 2 electrons that we had left over from our pot, we're going to put them with the nitrogen. And so you basically redraw the structure with those 2 lone pair electrons with the nitrogen. And step number 5 says if central atom does not have a complete octet. You're like, oh my gosh, it already does. So actually for that box you can put Na, not applicable. And then at the bottom of each column, for each structure you draw, we have some checks. So the first check is to look at your final Lewis structure in step 4 and see how many electrons you have. And I count 8. So that check matches with the 8 in my first box. So that's good. The next check is, does each atom, there's 4 atoms, the nitrogen, 3 hydrogens, do they have a rare gas configuration? Nitrogen has an octet and hydrogen have duets, so I'm like, cool with that. And the last one, last check only applies if it's a neutral molecule. And you know it's a neutral molecule if it doesn't have a little charge up there. So it's neutral, and so we would expect it to follow those valence rules, which remember valence is 8 minus the group number. So the valence of nitrogen, which is 5, is 8 minus 5 is 3. So actually nitrogen is reaching out 3 times, so it follows the expected valence. Hydrogen we expect to reach out once, so yes, so that check is good too. And then for each of things that you draw, you need to answer these questions about the middle atom. Remember, we talked about electron pair geometry around an atom, and somebody has to tell you what atom is in question, and I'm telling you it's the central atom. So nitrogen, let's see, remember you count sigma bonds and lone pair electrons. So I got 3 sigma bonds and 1 lone pair electron. So 3 plus 1 is 4. So I've done this some other years. So I have these. I think you already have these. But here's a copy for you because it's so important. So the fact that there are 4 things extending from that nitrogen atom, then you can answer all these questions. So it's sp, just like we did in class. So it's sp3 orbital hybridized. It's tetrahedral, and the bond angle is 1:25.
If you have one, okay, I know this isn't even a thing, but if it was this, isn't that the one that's like 105? You have to do that. Or...
You still would call it 1:05.
Okay.
Yeah, she's asking like in water.
Yeah.
No, you could still call it about 1.
Okay.
Yep. Yep. Very good. Okay, so now comes the fun part. So grab your thingies.
These things just...
Next one. Let's see. How can I speed it up? Faster. I know. Okay, so here we go. This one is dun dun dun. It's H2CO. H2CO, and sometimes students kind of work. You can kind of watch as I work, or go ahead and work ahead. I'm fine. So there's 2 hydrogens. They each have 1 valence electron, so 2 valence electrons there. There's 1 carbon. It's 4A, so there's 4 electrons for that. 1 times 4 is 4. There's 1 oxygen atom. Oxygen is a 6A, so that means there's 6 valence electrons. And so our pot of valence electrons is, I got 12. So the next step, we need to figure out what's going to go in the middle. It's not going to be hydrogen, and so it's either going to be carbon or oxygen, and I see some of you looking at your periodic table, and it's going to be the one that's less electronegative. So it's carbon. So carbon's going to be in the center, so then our preliminary Lewis structure looks like this, with carbon in the center, reaching out to hydrogen and oxygen. So that's the box underneath it.
Okay, is there a reason you put another hydrogen at the top?
No, you can,
Okay, because I have the other.
yeah, there's 2 hydrogens.
Yeah, but is there a reason you put them in that order?
No, there is no reason. There is totally no reason. Yeah, that's what I thought you were asking. You can put anybody in north, south, east, west position, yeah. So when I'm coming around, sometimes your Lewis structures look different, but they're the same. Yep. So I guess we have a pot of 12, and we've used 6 there. So we got 6 left over to deal with. And remember I said we satisfy our outside atom? Well, in this case, it's oxygen. So oxygen's going to take all 6 of those. So then our next structure in the box underneath it is going to be basically the same thing. Carbon, single bond hydrogen, single bond hydrogen, single bond oxygen. But now the oxygen, we're going to go ahead and take those 6 electrons and put them in pairs around the oxygen so that oxygen has an octet. So now actually step 5 does apply. And we talked yesterday about swinging lone pair electrons in to make a pi bond, so that in this case the carbon atom can get a complete octet, and that's exactly what we're going to do. And again, to kind of what Megan said, you can swing any of these in. It's your choice. So I swung the north one in. So when I do that, then in my next box, I can go ahead and write now carbon sigma pi bond. And now my oxygen, instead of having 3 lone pair electrons, only has 2 lone pair electrons. And then we need to go check our checks. So in that final Lewis structure, I got 2, 4, 6, 8, 2, 4, 6, 8, 10, 12. I got 12 electrons. Okay, so that check is correct. We need a pot of 12. We have 12 on our final Lewis structure. I could go ahead and draw little Venn diagrams around a carbon. So carbon has 8 electrons. Oxygen has 8 electrons. Those are octets. And of course, hydrogen's got a duet, so that's great. And since this is a neutral molecule, we expect it to follow its valence rules. So the valence for carbon is 8 minus 4, or 4. So it's reaching out 4 times by 2 sigma bonds and 1 pi bond. Oxygen's 6A, so 8 minus 6 is 2, so oxygen's reaching out twice, so that's wonderful. So what do you guys think? What column do we use for, how many carbon atom? How many sigma bonds? 3. How many lone pair electrons? For carbon, none. Yep, so we're going to go with that middle row. So what's its orbital hybridization? sp2, structural geometry, trigonoplanar, and bond angle 120. So let's make that structure. Okay, so the next one we're going to do actually is hypochlorite. That's one of the ones you need to know for Thursday's possibly know. So hypochlorite. Yes, it will be in brackets, exactly. There's only 2 atoms. It'll be in brackets because it's got a charge. So our final Lewis structure has to be bracketed. So, but when we come up with the pot of valence electrons, we only have to worry about chlorine and oxygen and the fact that it's got a -1 charge. So chlorine is 7A. So there's 1 chlorine atom. So 1 times 7 is 7. Oxygen is 6A. 1 times 6 is 6 electrons. And then the fact that it's -1. Now, if it had been -2, we would put 2 electrons. -3, we would kick in 3 electrons. So kick in 1 for the electron. So if you add that, you have a pot of 14 electrons. Woohoo! That's a lot of electrons for 2 atoms. So the next step is to draw the preliminary Lewis structure. So if you don't mind, I've kind of randomly chosen the oxygen's going to be our central atom, if that's okay with you. So basically, we only have 2 electrons in our preliminary Lewis structure. So 14 minus 2 is 12. So we have 12 electrons to distribute. And again, I would put them around the terminal one first, which is the chlorine atom, and then around the oxygen if you have any left. So it looks like the chlorine wants 6, and the oxygen also wants 6, doesn't it? So yeah, it equals 12. Ka-ting. So actually step number 5 does not apply because our oxygen, we had plenty of electrons to make it happy.
Can you triple bond them in the middle?
You can. There are some structures that need bond order of 3, yeah.
Okay,
6.
so should you or no?
We don't need to here, but
Just curious.
you do have, I think you guys have the ones that you're going to do that will need a triple bond today. So, but one of the things, let's see if I did this. Oh yeah, just like Megan said, if it is a polyatomic ion like this, you have to, your final Lewis structure, to get full credit, you always have to put brackets around your Lewis structure and put the charge outside. Okay. And then step number 5 is not applicable. So if we look at the total number of electrons, there are 12 on our final Lewis structure. Excuse me, 14. There better be 14. 2, 4, 6, 8, 10, 12, 14. There's 14 on our final Lewis structure, just like our pot. Both chlorine and oxygen have a complete octet. And actually, the last check does not apply because it's not a neutral molecule. It's an ion. So honestly, chlorine we expect, since it's 7A, 8 minus 7 is 1. We expect the halogens to reach out once. But oxygen is a 6A, so 8 minus 6 is 2. We expect it to reach out twice, and it's only reaching out once. But it's a neutral molecule. Then the last one, we pick on oxygen. So how many sigma bonds extending from the oxygen atom? 1. How many pairs of lone pair electrons extending? 3. So 1 plus 3 is 4. So again, you're after that, everything down here. Okay? So of course, yeah, it's kind of, it does, it's looking kind of creepy dark. It's sp3 orbital hybridized, it's tetrahedral, and the bond angle doesn't apply because there aren't more than one atom. So go ahead and make that polyatomic ion. Among other things, nitrogen. So N2, pot of valence electrons, it is a 5A, so we have 2 electrons times 5, so 5 each, so we have a total of 10 electrons. That's it. 10 electrons. So draw our preliminary Lewis structure. Nitrogen, single bond nitrogen. Let's see, do I do something here? Okay, so with that preliminary Lewis structure, we only have 2 electrons used up. So 10, which is our pot, minus 2, which we used, we have 8 electrons to distribute. So just for kicks, again, if you're okay, I'm going to go with the central atom on the right and the terminal atom on the left. So you're going to see me take 6 of those 8 electrons and put them around the left one, and then I have 2 electrons to go ahead and put around the right one. Okay, so remember, you satisfy your terminal atoms first. So it looks like this. So the left nitrogen has 3 pairs of single bonds, and then sigma bond nitrogen, and then we have on our central atom 2 electrons, but 2 lone pair electrons. But our central atom is not happy yet, so we've got to do step number 5. So that central atom only has, what, 4 electrons now, so it needs 4 more, so we're going to have to swing 2 pairs. So Megan, we're going to make our triple bond here. You get to pick your 2 you want to swing, convert lone pair electrons to pi bonds. Okay, and then for that last box, it looks like this, where now the left nitrogen has one pair of lone pair electrons left. Then we have a triple bond to the other nitrogen, and of course the other nitrogen just had its lone pair electrons. 1 pair of lone pair electrons. Does that make sense? So on our final Lewis structure, we have 2, 4, 6, 8, 10. That's cool because that was our pot. On our final Lewis structure, they both have 8 electrons around each. And since it's a neutral molecule, we should expect it to follow the expected valence rules. Nitrogen is 5A, 8 minus 5 is 3, and it's reaching out 3 times, so that's awesome. So it's symmetrical, so pick a nitrogen. How many sigma bonds staying from either nitrogen? Sigma bonds. Primary bond.
1,
Just 1. Why is it just 1?
because the other 2 are pi bonds.
Mm-hmm. Yep, so...
Oh, I thought you meant all together.
Nope, just 1 atom. Yeah, just pick an atom. We have 1 sigma bond. Perfect. And then how many lone pair electrons? How many pairs of lone pair electrons?
1.
Just 1 pair. Yeah. So we're back to that top row. So we're going with 2. So orbital hybridization. SP. Geometry linear, bond angle 180. So make that molecule.
Is this?
It is.
Mine doesn't want to stay
It looks like it wants to go
together. I know.
or something like that.
It took me forever just to get it to get together, so I'm really looking at it now.
But can you almost feel the strength in that triple bond? There's a lot of strength in the triple bond.